What happens if a human enters a black hole? According to current scientific theories, especially general relativity, the changes a human body would undergo as it approaches a black hole can be explained in the following stages and effects. 1. Strong gravitational field and tidal forces. Black holes possess an extremely strong gravitational field, and this gravity does not diminish simply as the inverse square of the distance. Rather, it increases dramatically as one gets very close. Different parts of the body, for example the feet and the head, experience different gravitational accelerations due to this gradient. This difference in acceleration is known as tidal forces. Second, spaghettification. Under the influence of tidal forces, parts of the body that are closer, for example the feet, experience a much stronger gravitational acceleration. This causes the body to stretch vertically and compress horizontally. This phenomenon, called spaghettification, refers to the process in which the body gradually transforms into a long, thin strand, resembling spaghetti. In this process, the internal cohesion of the body's tissues cannot withstand the tensile forces caused by gravity, eventually leading to the tearing and disintegration of the tissues. In particular for black holes with relatively small masses, for example roughly the mass of the Sun, it is predicted that the body would disintegrate due to extreme tidal forces even before reaching the event horizon. Third event, horizon and time dilation. To an external observer, as one gets closer to a black hole's event horizon, gravitational time dilation becomes more pronounced, making the falling object appear to move increasingly slower. As a result, a human falling into a black hole might appear to freeze from the perspective of an outside observer. However, the proper time experienced within the body continues to flow normally, and the deformation caused by tidal forces continues unabated. 4. Inside the black hole and near the singularity. According to general relativity, once an object crosses the event horizon, no force can allow it to escape from inside the black hole. The body will continue to be drawn toward the center of the black hole, the singularity. Near the singularity, the structure of space and time becomes extremely distorted, causing the current laws of physics, general relativity and quantum mechanics, to break down entirely. Therefore, existing science cannot predict exactly what will happen at the moment the body reaches the singularity. However, it is assumed that as the body gets closer to the singularity, extreme tidal forces and extreme curvature will have already completely disintegrated the body. Conclusion. In summary, if a human approaches a black hole, the body will first undergo the process of spaghettification, being extremely stretched and compressed by tidal forces due to the steep gravitational gradient. During this process, the body's tissues are destroyed and eventually disintegrate. By the time the body crosses the event horizon and approaches the singularity, the known laws of physics no longer apply. However, even before that point, it is scientifically predicted that the body would have already been destroyed by extreme physical forces. All of these processes are predictions based on current general relativity, and because the conditions under which a human or any object falls into a black hole are extreme, experimental verification has not been achieved.